Thank you, thank you. Yeah, so this will be a short, brief report on lessons learned from, on this exact topic and our collaboration with IDC and especially Marius Popa. Are you here, Marius, by the way, if there are questions? There you are, good. Later, maybe. So, yeah, let's go. So the story for us started really with that we are rebooting the waveform work at FY since quite a few decades with low activity, one person working on this topic at NDC. Now we're in a build-up phase. We have roughly 5 people now working full-time in seismology, geophysics, and meteorology. And what we realized then was working with modern waveform research really puts new demands on IT security and the way we implement, what was the word now again? ICT? Yeah. I learned something at FY. So the key challenges that we face is really connected to the real-time data requirements in waveform research. That real-time data means that you're continuously exposed to people around you, right? And that creates a persistent entry point then for attackers, as I wrote there. And we would also like then to include GCI into this somehow, and then also be able to provide an FDSN or SeedLink server for communication out again from our institutes. So I think this is the same like most institutes, the same issues that most institutes have, right? Just a quick summary of on the waveform side of things, the 2 protocols or architectures that are relevant. The most relevant ones, at least. So SeedLink is the protocol used for real-time streaming. It's just a TCP/IP protocol on port 1800, which is typically not encrypted. You can have encrypted SeedLink, but at least we don't use that. And then it's FTS and web services, which is a RESTful web service interface and architecture, which is also not encrypted, for on-demand data, but also to request metadata. This is for the non-waveform people out there. All right, so that's the 2 data streams that we have. And what do you need? You want to be able to have data flowing into the house and out from the house, and also in real time, as I just said. But you also want to be able to monitor the data as it flows in to make sure there are nothing shady going on. And you also want, of course, to put up various types of gatekeepers to limit the network traffic. And speaking of IMS and GSI, you also, of course, then want software to be able to receive this data and other types of software needed, say, like a SeedLink client server and stuff like that. And in the end, find a good balance between protection and functionality, because in the end, you want to work with this data to a satisfactory degree, of course, otherwise it's not worth it. So what do you want to do? You want to set up an intermediate server, probably. That's the standard solution in a demilitarized zone, for example, if that is what your institute can provide. Install all the necessary software, as I said. And here for us, it was key with CTBTO's new software VPN. So we'll come back to that. And then you have this server, and you allow for data streams through that into the internal network, the secure, high-security network that you might have. But how do you do that in a good way? So this was the struggle for us in collaboration with our own IT staff to figure out a way to do this in a safe way. We started by looking into SSH port forward, but that in the end did not work because SSH, as you know, is encrypted, which means that you cannot monitor the data. It will become, it's its own separate thing that is inaccessible really from the outside, to put it very briefly. But then we figured out, which is, I guess, also a standard solution. I'm sure many of you already have this, but I still want to say it in case it could be, it's something that you didn't realize. A reverse proxy is much better. Then you can collect all data into this reverse proxy and stream the data through that into your internal network and have either yourself or your IT staff monitor the data stream through this. Yeah, and of course firewalls and all that connected to this. So a brief summary of the software VPN by GCI. I think Marius just had his poster upstairs, so if you have any questions on detailed questions, you can go and talk to him. But the motivation, as far as I understand, behind why IDC developed this new solution was that more and more NDCs wanted to have their servers in the cloud. So that was the initial motivation, but then it also fits very well with the needs that we have with thus allowing us to put the VPN on in a DMZ. And it's also flexible. It's a Docker solution that you can play around with yourself, really, to tune it to your security needs. So that's something that we did a lot together with our IT staff to make sure that it's functioning to their satisfactory from their perspectives. And you can deploy it on any Linux-based platform. It has automated monitoring and alerting. And it has this unique disaster recovery concept that Marius and IDC has developed. So that's also very interesting, but I'm not going to go into details about that here. So just sort of summarizing the science sketch. Start with the internet. Have you heard about that? All the open data sources available. So you heard about the internet. National data from your national stations, of course. That could be closed or open. You have the CTBTO IMS data, which is closed. And you have the collaborating institutes. Real-time data, on-demand data. Okay, through the initial firewall into this outer DMZ server, or network, really, with a less strict firewall so that you can get the data that you need into this. And here you deploy bare bones, say, SeedLink, FDS, and server clients. Also, here is where you would place your GCI VPN, or at least that's where we have this GCI VPN. And then you set up this reverse proxy on this server, collect all the data into this, stream it through as locked down firewall as you can through this single proxy. I just put name institute.eu, and then you have ports. So you can say you have 20 different SeedLink streams. You can have them at the different ports. And then at the bottom there you see the monitoring. This is then where your IT staff would sit and look and monitor the data, check. Yeah, I'm not going to go into details on how we do this, of course, but I think you understand the concept. And then you just do your normal processing, starting from a receiving server that you then can connect to as normal, but inside your network. Here I just put some SQL databases for our radionuclides and SHI, your personal computers, other servers. Yeah, it's just representative of what it could look like. Yeah, that's it. So I think this is nothing super fancy or something new really, but it was super helpful to us. And I think the goal here is really to inspire other NDCs to maybe do the same if they haven't. And I'm also very grateful to the collaboration with IDC on this. This has been fantastic. So yeah, that's it. Thank you.
Thank you very much for this interesting talk. And this is a very, very specific topic. So I hope there are experts who can ask very, very specific and interesting questions to further develop this topic. Thank you very much. I don't see many volunteers.
No, I didn't expect any, really.
Yes.
But happy to take questions afterwards and discussions with me and Marius if you have any.
Yes. Please also don't hesitate to contact directly the speakers if you have very, very specific and detailed questions. Overall, we have some time left to this oral session because this was the last presentation of a session.